And we are back. Hello everyone. I can't believe here again. Episode I think number 7 now. This is going really well. The feedback is amazing. Like I have people pinging from Twitter, YouTube. It's really great. Thank God only very few issues, but most of the people can proceed almost smooth. This is great. So welcome to yet another episode on how to build a Cardano stake node with Raspberry Pi. So the last time I left you with downloading the blockchain and getting sync up with testnet. Someone has already done mainnet as well. It takes forever, I know, and I'm aware. I did an extra episode as well about the crashes of the Cardano node. This is normal. If you're downloading either testnet or mainnet all in one go, from time to time the node will crash. It happened to me in the past. It doesn't happen to me anymore because I'm doing regular backups of the blockchain. So whenever I'm moving things around, I can just re-explode the blockchain and it will just have to sync up from a week or a month, but not the full blockchain. So yeah, without further ado, let's go into the next episode. Today, we're going to be talking about security. We will not go too mad into that, but today we're going to be increasing the level of security on the SSH daemon. So, because some keys are going to be leaving on the Raspberry Pi and we don't want anyone to steal them, we have to try to reduce chances of an attacker to get access on the Raspberry Pi. And there are several ways we can do this, but one super simple that is a must-have is the one of disabling password access on the Raspberry Pi. And we will only going to be using SSH keys to access on the Raspberry Pis. Beside the fact that we're going to increase the level of security, it's going to be nice as well because you will not have to enter or remember the password anymore if you use a passwordless SSH key. Alternatively, you can set a password on top of your SSH key so that you have a double layer of security. The keys per se plus the password to unlock the key. So I just want to remind you that my name is Giovanni, also known as CryptoJo101 on Twitter. And if you like the content of the videos that I'm providing you with, I am a stake pool operator as well. So if you like this content, please consider delegating to my stake pool. That is easy one. So yeah, thank you very much. So let's go into the tutorial. So nicely enough, the dark mode for GitHub was just released and I am like, wow, let's give it a go. So this is the latest and greatest version, just updated of the tutorial, just updated 7 minutes ago. And the new section we're going to be talking about is the section number 6. Disable password auth mechanism for SSH. So click onto the docs, and this is the new step of the tutorial. So here there is a little bit of writing, but it's pretty much what I told you already. The SSH daemon that we've enabled in the first or second episode of this tutorial comes with the username and password authentication mechanism enabled by default, because this is basically the only one way to access the Raspberry Pi. Of course, if you want to increase the level of security, we can work around that and make things a little bit nicer and more secure. Before proceeding to the next, to the actual implementation of this tutorial, I just want to say that I'm pretty sure that most of you, or a larger majority of you, especially Unix or macOS user, you could already possibly have a pair of keys into this folder. It is a .ssh into your home folder, because if you use GitHub or many other things, it works out really well if you already have keys. So if you want to reuse exactly the same keys that you're already using so that you don't have like an explosion of number of keys to manage, because the many you have, the harder it is to use, you can basically just reuse those ones if you have a copy, if you know that no one has, and if you trust the keys that you have and you know exactly what you've been using them for. So maybe for this tutorial you can just reuse them, but otherwise if you just want to go like for the highest level of security, just generate brand new keys and go with them. We're gonna be doing this anyway in a minute, so yeah, it's up to yourself. The command that we have to use is our SSH keygen. Just for clarity, this generation of the keys has to happen on the machine that you're using to SSH onto the Raspberry Pi. So this little bit has to happen on your laptop and not on your Raspberry Pi. On the Raspberry Pi, we will possibly, I'll show you later on what we have to do, but all that we have to do is to publish on the Raspberry Pi the public key of your set of keys. And while your private and most important, your public and most importantly private key will have to stay on your laptop. If you copy those ones as well on the Raspberry Pi, it doesn't work that way. So without further ado, let's do this. SSH keygen. This is my laptop. I'm already into my SSH folder. The first thing that I'm going to do is to check if I have anything. And I don't have anything. Forget about this orange because these are like my work keys and we don't have to use them. So we just want to generate new ones. So you can change directory in whichever folder and we go SSH keygen. So as soon as I hit this one, it's going to ask, where do you want to save the keys? Because the default folder, if you don't want to specify every single time where the keys are, it's better just to put them into the default folder. SSH agent or daemon will just go straight away into this folder to load the default keys. So for simplicity, I'll just say let's use just the default key. Enter passphrase. You have to definitely put a passphrase and then confirm it on the next step. I'm just gonna skip this thing because my memory is very bad and I'm doing this just for the purpose of the tutorial. So I'll skip it and I'll go empty. But you definitely have to do this. So create your passphrase and happy days. So what happened after this? So we just go back into the SSH folder. We issue again on ls-lart and all of a sudden we have IDRSA and IDRSA pub. Just please notice that especially the private key, it has a very particular mask here that is 400. So if, and I think this one is 422 or 411. Anyway, the most important thing is those keys, they have the correct access so that they can be written by the root. And the same thing here, and can only be read by all the user, and I can't remember what the last one stands for, but yeah, they can only be read and not written because this could compromise the security of your keys. So this is the first thing, very easy, takes 30 seconds to do. Now what we have to do, remember to save a copy. If you have something like LastPass, LastPass is fantastic because it has exactly a pair of keys as an entry. If you want to save SSH keys, it has like a special section just for this where you can put your private and your public and your private key. Now the next thing is these steps are taken from this tutorial. Actually I'm going to be opening. So if you want to read the full shebang, I definitely recommend you to go here. Ledger Nano S. I definitely have been on the Ledger website. So in here there are explained all the detailed steps of the process. I'm just gonna go through straight to the point, and we're gonna just do the minimum required just to get things done in the safest way. So the first thing that we have to do is to basically, so very briefly how it works. We have a private key, and for this private key there is a public key. We're going to be installing the public key, the key that can be known by everyone on the target server. Whenever we SSH, basically there is an exchange between a public key and the signature that is done with the private key, so that we can demonstrate on the target server that we own the rights to access that server, because with our private key, because we own the private key that generated that public key. In this way, we are granted the access. So what we have to do is to keep the private key on our laptop and then to install the public key on our Raspberry Pi. So the step of doing this is very simple. And just bear in mind that the IP address here is the IP address of my Raspberry Pi, but please replace with this IP address with one of your Raspberry Pi. So I'm gonna just copy this one I'm gonna change directory into the directory where my ID RSA, the private key is. Oops. Let me copy this one again. And then we hit enter. So this is gonna be hopefully the last time that we're gonna be entering the password. That is still raspberry, I think. And there we go, the key has been added. So now if I try to do SSH-L Ubuntu and then the IP address, I think I shouldn't be prompted for the password anymore. Ta-da! You see, no password. And we are still into the Ubuntu as before. So first step has been done. So do we want to check exactly what happened here? So if we go into SSH, that is exactly the same folder as the one where I was working on my laptop, and I'll do an ls-lart, there is a file called authorized key. If I do a cut of this one, there is going to be, I think, a couple of keys. I think it's the same keys twice. No, sorry, yeah, it's 2 keys. I tried the very same thing like 5 minutes ago. So, so this one was created while I was writing the documentation, and this is actually, I think, the one that has been just literally just created. Let's make a quick test. So I'll go into SSH again, and I'm gonna do like cat idrsa.pub this time around, and let's see if I can find this very long string. In this case, Command F, tada, there you go. This is exactly the key that was the public key that was copied from one place into the other place. So technically we could have done this thing manually, but why doing manually is there is an SSH command that does this thing for us. So let's close the previous, the new tab, and let's go back to this one and we clear, and then we continue with our tutorial. So we have set up the proper IP address, and now we're going to be entering the password for the very last time, and now we can proceed with editing the SSH daemon configuration. I'm going to be copying this command and then briefly explain what we're going to do. So there are 4 things that we have to ensure that are set to no. The two main one are use spam and password authentication. That could definitely password authentication is set to yes, and the pluggable authentication module I think is also set to yes. Those 2 have to be set to no, because this could be possibly be targeted with a brute force approach. And basically, if there is someone that wants to hack your Raspberry Pi, could just set a script that tests for days and days, if not weeks, to guess username and password. So if your username and password are not strong enough, usually it's always Ubuntu the username, because that's the one that we've set up, and people just change the password for that. So half of the work has already been done. So we just have to guess the other half. But if we disable password authentication altogether, while they may still know that the user is Ubuntu, but if we use an SSH key that is like, I think 256 bytes is a good challenge. It's gonna take years probably to break into that, if no more. So these are the 4 parameters that we will have to change. So let's edit this. So this is the configuration. The first thing that we're going to be looking for is a challenge response authentication. I'm going to be using / and then paste to find this entry. And the first one is already set to no. Technically, you should see exactly the same thing that I'm seeing, because we're using exactly the same distribution. The next thing that I'm going to be looking is the password authentication, and as you can see is set to yes. So I'll press ask again, and then I'm going to be editing this one, and then I can use escape character CW, that means change word, and then it is automatically in insert mode, and I'm going to be writing no. Then I'll press ask and then semicolon W to save the changes. Let's go to the next one. Use spam / and then Command V, and we are in PAM. Sorry, enter, and then change, move to the yes. CW for change word, and then we do no again. Ask semicolon W enter again. Last but not least, permit root login. I think this is already disabled. It's actually commented out, so there is permit login. Yeah, you can search by either slash and paste, and then if you want to go to the next, and just press enter, and then slash without writing anything, and then enter again. It's gonna go to the next one. So you can slash enter slash n to navigate through the document. So that's it. We've done it. Command Q, exclamation mark. Just to double check, we'll go into that again. Let's see. Let's look for use. PAM set to no. And then the other one I can't remember is password authentication. There we go. We go here and we set this one is already set to no. And there aren't any other one. It's all set to no. Fantastic. Esc. Semicolon Q, exclamation mark. Boom, the configuration has already been updated, but now we still have to ask the daemon of SSH to reload the configuration so that all those changes are gonna take effect now. So you just issue the command and it should be done. We do exit, and then let's try to do this. Let's change the name. Let's move mkdir backup, and I'm gonna be moving IDRSA star into backup, so that we're basically removing the SSH keys. So you remember that earlier on I did my SSH like this, and I wasn't prompted for the password because the SSH keys was there, and then I authenticated with that. But the SSH key there is not there anymore. So if I do this, it's gonna fall back on password. But technically, because password is disabled, these things should just like bomb out in my face and say, then a public something denied. That's it. There is no way I can authenticate because password authentication has been disabled. If you really want to go into more details, blah, 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 increase with the -bbb, the verbose, read the logs, and you will see that it's basically telling you that it's going to try to go for username and password, but username and password has been disabled, so you're going to be disallowed. So we go into backup, and now we move everything down one layer, and I'm going to remove backup. So if I do SSH now, exactly the same that I was doing before, because the keys are there, the SSH daemon is loading the keys on the fly and granting me the access. So let's go back out again. There is one more thing I want to show you. There is a way of forcing the SSH to use preferred authentication password and public key authentication. So we're basically saying don't use pub key, just go straight away for authentication. And let me remind something. I think I still have to do Ubuntu at 192.168.0.215. Sorry, -l Ubuntu, so I just have to put this one. And again, straight away denied. I'm saying just use password, don't use pub key. And again, in this case, it's just saying F off, you're not authorized. There is no way we're going to be letting you using the public key, the password approach, but only exclusively the public key authentication mechanism. So if we do again just SSH L Ubuntu like this, no password anymore, at least in my case. In your case, I would stay strongly recommend to use the password and you will be in. So I think this should be it. Yeah, that's it for today. So in this way, we increased the level of security for Raspberry Pi. There is an extra thing that we could possibly do, but it really depends on the configuration of your network home. So I'm gonna just spending these extra 3 minutes trying to explain this concept to you. If it is a little bit too complicated, just ignore it. While if you are a little bit into networking, this could actually be useful. So basically what happens is that the SSH daemon is listening for incoming TCP connection on the network interface, and I think the port is the port 22. So whenever there is a connection to this port, the SSH daemon accepts it and that starts to manage the the authentication mechanism, the login, etc., yada yada, so that you can SSH onto the box and start to control the box. Many people are suggesting to move to change the default port from 22 to another number, because this is gonna make like a little bit more complicated for attacker, because the 22 port will not be used anymore. Another port, random port, will actually be used. The thing is that nowadays port scanner are very, very common. So if the port 22 is closed, 99% of the cases another port is open. So people just execute the port scan, challenges whichever port is open, and because the OpenSSH protocol is well known, it's very, very easy to check if the port on which they are challenging is a receiver port of an OpenSSH daemon. So you potentially could change that one. I actually don't think it's gonna make a hell of a difference. The reason why I'm saying that is because most likely if you're doing this thing on Raspberry Pis, you're actually working on your private network at home. That should already give you some sort of security, because unless you're given your Wi-Fi password to everybody in your estate, the access to your network should be already very limited. If there is a router in front of your connection, malicious people should hack the router first, get into the network, and then SSH on the box. This is definitely possible, but unlikely. For my understanding and based on my experience, I really hope no one is going to try to hack my Raspberry Pis, but I think just disabling username and password authentication should give you enough security to at the end of the day. I really hope that in the next tutorial, whenever we are dealing with keys, you're only going to install the bare minimum amount of keys on the Raspberry Pis and not the cold key and whatever, so that you're really screwed. But just the 3 keys that you're going to be, the VRF key, the operational cert, and then the KES key. These are basically the KES key. These are the only 3 keys that you should have on the Raspberry Pi, and all the other keys should be safe on whichever other laptop or computer you own. And that's it. With this, I'm closing this episode. Thank you very much for following me. Remember to subscribe, smash like on this YouTube video, and remember, I'm a stake pool operator. The ticker is EASY1. If you like the content of this video while you're setting up your Cardano stake pool, if you like the content, stake on my stake pool. Ticker is EASY1. Thank you very much, and I'll see you at the next episode. Bye.